So we're going to explore or review exponents and radicals. It's a new unit, but we're going to look at laws of exponents first. So all of this should be a review of Algebra 1. There is nothing in here that is new other than perhaps, no, there really shouldn't be anything new in this one. So let's go ahead and quickly go through some of the stuff. So most of you think that when I say a power, that a power relates to an exponent. But this whole thing here is a power. The base and its exponent, the whole thing is a power. So even though I might say something like 2 to the third power, that's why you guys think that this is the power. The whole thing, the base of 2 and the exponent of 3, all of that is considered the power. So the definition of a to the n really means, let's say that I had 2 to the third, it means 2 times 2 times 2, which would be 8. Where a to the negative n, let's use the same theory, but we'll do 2 to the negative 3. Anytime you have a negative exponent, right here, that does not mean that the value of the power is negative. This is shorthand notation for take the reciprocal of my power. So what we're going to do is we're going to put this 2 to the negative 3 over 1, and if you want the exponent to turn positive, you just have to push it in the opposite direction. So in this case, we're going to take 2 to the negative 3 and put it in the denominator. And so as soon as you put it in the denominator, the exponent turns to a positive 3. Well, that means that there is nothing here in the numerator. So if there's nothing left, there's always a 1 there. And so then this ends up being equal to 1 over 8, because 2 times 2 times 2 is 8. Then a to the 0, anything to the 0 power is always equal to 1, not 0, but 1. And the reason for this is, let's take 2 to the third and kind of look at that again. If I took 2 to the third and divided it by 2 to the third, what is anything divided by itself? 1. So you already know the answer to this is 1, but let's review when dividing like bases, we subtract exponents. We've talked a lot about that. So because we are dividing like bases, we are going to subtract exponents, and I always suggest that you subtract where there are more. Well, because 2 to the third is the same as 2 to the third, there really, one isn't bigger than the other one, then I would suggest you subtract in the numerator. So we're going to subtract 3 of the 2 cubes with 3 upstairs, and I end up with 2 to the 0 over 1, which is 2 to the 0, which we already said had a value of 1. So anything divided by itself is 1. To get anything to the 0 power, we essentially took the same thing and divided it by itself. That's how we got the 0 power. And so anything divided by itself has to be 1. So the shortcut, anything to the 0 power is 1. So then I want you to pause the video and do these 4 problems on your own and see if you can get the correct answer. So pause the video, really pause the video. Okay, so hopefully you actually pause the video and actually have the correct answer. So 10 to the negative 1, I'm going to take, because it's a negative exponent, I'm going to put it over 1. Because it wants me to take the reciprocal, so I'm going to push it in the denominator. So it becomes 10 to the first in the denominator. There's nothing left upstairs, so it's 1, and so it's 1/10. Then this one here, same thing, it's to the negative 2, so we want to take the reciprocal. So I'm going to put 10 to the negative 2 over 1, so I can look at it like it's a fraction. Take the whole thing and push it into the denominator. So we get 10 to the positive 2. There's nothing left up top, so there's a 1 there, equals, and you actually have to multiply out that 10 times 10. So 10 squared is 10 times 10, which is 100. All of this is being raised to the 0 power, so anything raised to the 0 power is 1. then this is separate from this. So the value of x to the 0, anything to the 0 power, has a value of 1, so that's really 1 times. And then we're going to take y to the negative 3 and put it over 1. And they're going to move this into the denominator. So I have to create a fraction. So we're going to put y to the 3 in the denominator. So 1 times y to the 3rd in the denominator is just 1 over y to the 3rd. So again, this kind of disappears because anything to the 0 power is 1, so 1 times y to the negative 3 is y to the negative 3. So to get this positive, we're going to push it down the denominator, so we get y to the positive 3 with a 1 up top. So this is just putting all of our rules that we've talked about together. I'm going to give you a couple of real number examples so that you can see how the rules work with those real number examples. So the first rule, multiplication rule. So when multiplying like bases, we add the exponents. So if I have 2 to the 3rd times 2 to the 2nd, we're going to add those exponents and get 2 to the 5th. And of course you'd multiply that out, which is 32. But I ran out of room. And then for the division rule, we might have, and it doesn't matter which one I put up top. So if I have, not 3, 2, let's try that again. I want to use my same numbers. So if I have 2 to the 3rd divided by 2 squared, you're going to do your subtraction. So when dividing like bases, we subtract. So you're going to subtract where there are more. So all of these will subtract with 2 of those. And so we end up with just a 2 in the numerator. There's nothing left in the denominator, so there'd be a 1, which means that it would equal 2. Now this is one that you might not be as familiar with, power raised to a power. So you have a power inside the parentheses raised to another exponent. We are going to multiply those together. So you end up with x times y. So for instance, if I had 2 to the 3rd raised to the 2nd, we are going to multiply the 3 to the 2. So I have 3 times 2 is 6, so I would have 2 to the 6th. And why is that? Because this really means 3 cubed squared. So I'd have 3 cubed times 3 cubed, 3 cubed times 3 cubed, multiplying like bases, add those exponents, 3 plus 3 is 6. So this is just a shortcut. Power of a product rule. So the difference between this rule and this rule is this one has more items inside the parentheses being raised to a power than this one does. But it's essentially the same rule. Whatever's in here, we're going to raise to this exponent, as long as there's no addition or subtraction signs inside of there. So it might look like, let's see, 2x squared y cubed raised to the 4th. So you have to be careful because I'm raising the 2 to the 4th power, the x squared to the 4th power, and the y cubed to the 4th power. So these are power to power, and technically this 2 is a power to power, you just don't see its exponent. So I always like to have my kids put in the exponent there, and we're just going to raise this power to that power by multiplying. So the 1 gets multiplied to the 4, the 2 gets multiplied to the 4, and the 3 gets multiplied to the 4. So you end up with 2 to the 4th, then 2 times 4 is 8, so x to the 8th, 3 times 4 is 12, y to the 12th. And of course you would have to multiply out 2 to the 4th, you would get 16, but I don't have enough room to write that. Then the fraction rule. So if I have a fraction inside the parentheses raised to a power, I can separate that out and take the numerator and raise it to that power using the power to power rule, and the denominator raised to that power. So if I had 2 to the 3rd over 3 squared, and I've raised that to the 2nd. So we're going to split that up, and we're going to do 2 to the 3rd to the 2nd, and 3 to the second to the second. And so you're just going to use power to power. 3 times 2 is 6, so I'd get 2 to the 6th. 2 times 2 is 4, so I would get 3 to the 4th. And of course, you'd have to multiply those out. And again, we have what we just talked about. Anything to the 0 power is 1. And then anything to a negative exponent, you put it over 1 and take the reciprocal, so that ends up going in the denominator and becoming positive. All right, so here's some more complicated examples where we're using any of those rules. And so you just kind of have to talk yourself through it. Am I multiplying like bases? If so, I add the exponents. Am I doing a power to power? If so, I'm going to multiply exponents. If I'm dividing like bases, I'm subtracting exponents, that kind of stuff. Well, this first question, I have parentheses, but there's nothing outside here raising it to a power. So I don't have a power raised to a power. I don't have a power raised to a power. But what I do have is a monomial times a monomial. So I generally like to say you're going to multiply coefficient to coefficient, like base to like base. So coefficient to coefficient, 2 times 3 is 6. And then my like bases, I'm going to add the exponents. So I've got 2 plus 3. So my answer is 6x to the 5th. That's a 5. That's a 5. Looks like a 15 now. Then for the next one, I do have like bases. So technically, I have m to the negative 4 plus negative 5. So if I add those together, I get m to the negative 9. But you cannot have an answer with a negative exponent because it's considered bad form. So we're going to make it into a positive exponent by taking its reciprocal. So I'm going to push it downstairs into the denominator. So I end up with 1 over m to the positive 9. Then here I am going to approach this next problem separately. So I'm going to only look at the x's, then the y's, and then the z's. So we are dividing like bases, so we subtract the exponents and we subtract where there are more. And I will do my work piece by piece, bit by bit, so that I don't get lost. So I'm going to start with the x's. Since there are more x's in the denominator, I'm going to cancel all of these with 3 of those. So I end up with an x to the 4th in the denominator. Then the y's. There are more y's in the numerator, so this 1y is going to cancel with 1 upstairs. So I get y to the 3rd. And then your z's are identical, so they just cancel 1 for 1. Z to the 8th divided by z to the 8th is 1. So your final answer ends up being y cubed over x to the 4th. The next problem, we've got a power and a power raised to a power. So the power to power means we're going to multiply exponents. So I'm going to take the 3 and multiply it to the 5. So I get x to the 15th. Then I'm going to take the negative 2 and multiply it to the 5. And I get y to the negative 10. Then I need to take care of any negative exponents. So these actually move independently of each other. This is going to stay up top because it has a positive exponent, but this is going to move down to the denominator because I need to get its negative exponent to become positive. So only that y to the negative 10th goes down. The x to the 15th stays upstairs. So I have an x to the 15th in the numerator and a y to the 10th in the denominator. They are not like bases, so I cannot simplify any further. Then the final one has a lot going on, so I'm just going to take it piece by piece. I'm going to take coefficients, like bases, and just go with it there. So because I don't have anything to reduce or cancel this negative 2 with, because there's no other coefficient, then essentially we're going to ignore it and leave it where it's at. And just because it's negative doesn't mean you can move it downstairs and make it positive, because it's not an exponent. It's a number, so it has to stay there. Then, before I can try to divide when I divide like bases, I subtract the exponents. Well, I don't like all these negatives. So we're going to fix that by this one is going to get moved upstairs. And so I'm going to get an x to the 5th. And then this one is going to move upstairs. So I have a y to the positive 3. And then the z is going to stay downstairs. And then let's look upstairs. So upstairs I have a y cubed, so that's going to stay there because it's not negative, or y cubed and x cubed. And then this y to the negative 4th, it needs to move. So this is going to move downstairs. So I get a y to the 4th downstairs. And then finally, I have the z to the 7th. It's going to stay, because it's positive, upstairs. So now we're going to, now that we have all positive exponents, now you can divide like bases. But even before that, I've noticed that I've got like bases here, so I'm multiplying like bases in the numerator, so I still, before I even do any division, I need to simplify those first. So when multiplying like bases, we're going to add these exponents. So 5 and 3 is 8. So I have negative 2, x to the 8th, y to the 3rd, z to the 7th. And then the denominator is y to the 4th, z to the 2nd. So our final answer, I'm still not touching the negative 2. And then my x's, I don't have any like base to my x's here, so my x is going to stay the same as well. So I get x to the 8th. Then I am dividing like bases here with a y. So there's more y's in the denominator, so I'm going to cancel all 3 of these with 3 here. So I end up with y to the 1st in the denominator, so I'm going to just leave it as y. And then here I have more z's up top, so all of these are going to cancel with 7 of those. Or I'm sorry, not with 7, with 2. And so I am left with z to the 5th up top. And this becomes my final answer. All right, so this is just to remind you that when you're simplifying exponents, you still have to use, please excuse my dear Aunt Sally. So you still have to do parentheses first. So if there's anything inside of parentheses, you have to do it first. Then you can deal with power to power and do exponents. Then you can multiply and divide like bases. And then you can finally add and subtract like terms. Okay, so here we go. I want you to pause the video, and I want you to do all of these problems on your own, and then restart the video and see if you got them correct. So pause that video. Okay, so hopefully you pause the video. So I'm going to make this really big so that I have room to work. So we're going to start with this first problem here, right here. So right here, it's not just the y to the 4th that's being multiplied in here, and we don't really distribute it in here anyway because I don't see any addition subtraction signs. So I have this monomial essentially being multiplied to this monomial. So we're going to do coefficient to coefficient, like base to like base. So 3 times 2 is 6. And then x times, and this is x to the 1st, so you might want to get in the habit of putting a 1 there when you're missing an exponent. So 3 plus 1 is going to give us x to the 4th. And then 4 plus a negative 8 is going to give us y to the negative 4. Because I can't have a negative exponent, I'm going to put this over 1, and just this part is going to move down to the denominator. So we end up with a final answer of 6x to the 4th up top over y to the positive 4 in the denominator. So this problem here, we have a power raised to a power. Now mind you, this exponent here is 1. And so when we have a power to power, we're going to multiply this exponent to this, multiply this to this. and then we'll see what we have left. So right now I can't cancel these because this is in parentheses, so I have to follow order of operations. So I end up with 1 times the negative 2, so I get 2 to the negative 2. Negative 3 times negative 2 is b to the 6th, positive 6, all over 2b to the 4th. So I don't want to do anything until I have positive exponents. So this is going to get moved downstairs to where it's going to be positive. So I have a b to the 4th upstairs. Then I'm moving the 2 to the negative 2 downstairs, so it becomes 2 to the positive 2. I still have that 2 and then the b to the 4th. So now I am multiplying like bases. So I've got 2, and then that's 2 to the 1st. So 2 plus 1 is 3. So this gives me 2 to the 3rd. And then my b to the 4th are identical, or that's a, how did I get b to the 4th? That should be b to the 6th. So let's fix that. If it'll let me. Of course it won't let me, so I'm going to fix it. Somebody should have shouted out there to me, that's not b to the 4th. So what did I just do? So from here, that should have been a b to the 6th. I don't know how I got b to the 4th. So we clearly have more b's up top than we do in the bottom, so I'm going to cancel all of these with 4 of those, so that gives me a b squared up top. And so my final answer is going to be, I'm going to write it in black, is going to be b to the 2nd over 2 cubed is 8. So b to the 2nd over 8. All right, then this problem. So we have 2 powers to a power. I'll move it way over. So this is to the 1st, and I've got to multiply it to the negative 2, this to the negative 2, and this to the negative 2. So I'm going to go ahead and put a 1 here, and I also have a 1 here. Let's make that bigger. So I'm multiplying the negative 2 to each of these exponents. So that's what I'm going to do first. So I get 3 to the negative 2, a to the negative 8, and b to the negative 6, all divided by. Then I'm going to multiply the negative 3 to this one. Oh, and this one has an exponent of 1 as well, so let's put that in there. So I have 2 to the negative 3 and a to the negative 3. So if you've noticed, every single one of my exponents are negative. So if I just take the entire reciprocal icon, I'm going to take all of this and put it down here, and all of this and put it up here. So I'm just going to flip the whole thing and take the reciprocal of the entire fraction, and that means all the exponents are going to change to positive. So I end up with 2 to the positive 3, a to the positive 3, over 3 to the positive 2, a to the positive 8, b to the positive 6. Now I can deal with dividing like bases. So I have more a's in the denominator, so all of these will cancel with 3 of those, and that's really the only thing that I can do other than multiplying out my 2 cubed, which is 8, and then my 3 squared, which is 9. I'm left with a to the 5th in the denominator and b to the 6th. Let's go over here to this problem. So this one has a fraction raised to this negative 2. So remember that I can raise this to the negative 2 and this to the negative 2. So that's what I'm going to do. This negative is raised to that power as well. So really I've got a negative 3 raised to that. So it doesn't matter that that's a negative. A negative squared is going to be positive, so I'm just ignoring this negative. And then I'm going to put in all of my exponents that are 1, 1, 1, 1, 1, and 1, and technically 1. So power to power, I'm multiplying. So I get 3 to the negative 2, a to the negative 2, b to the negative 2, c to the negative 4, because negative 2 times 2 is 4, over 9 to the negative 2, a to the negative 6, b to the negative 2, and c to the negative 2. So just like the previous one, every single exponent is negative. So I'm just going to take the whole reciprocal. So I get 9 squared, a to the 6th, b squared, c squared, all over 3 squared, a squared, b squared, c to the 4th equals. So 3 squared is 9. So I'm going to do a couple things here. So 3 squared is really 9, right? And it's 9 to the 1st. And I only did that because I wanted to have like bases. That's a 9 and that's a 9. So I have more 9s up top. So I'm going to cancel these 9s, or that one 9, with 1 up here. So that leaves me with a 9 in the numerator. Then there are more a's up top. So all of these cancel with 2 of those. So I get a to the 4th. Then there are, the b's are the same amount, so those just cancel. And then we have over, there are more c's in the denominator. So these c's cancel with 2 there. So you have c squared in the denominator. So there's your final answer. All right, so let's look at these two problems. So for the first one here, I'm taking this negative 2 times this, but it's raised to the 4th power. So order of operations say I have to do power to a power first. So I'm going to ignore the negative 2x. I'm still going to write it down, but I'm not going to do anything with it yet. And then remember, this 3 is to the 1st power, and power to power, we're going to multiply exponents. So 1 times 4 is 4. 3 times 4 is 12. 2 times 4 is 8. Now we're going to do coefficient to coefficient, like base to like base. Well, this right here is 81. So 3 to the 4th is 81. And 81 times negative 2 is negative 162. And then this is x to the 1st. So when multiplying like bases, I'm going to add the exponent. So 1 plus 12 is x to the 13th. And then we're going to tack on that y to the 8th. There's that one. All right, so for this one right here below, I've got all of this raised to the negative 1. So I've got to multiply, because I got power to power, I've got to multiply this to each of these exponents. So this exponent here is a 1. And so let's do that first. So I've got 3 to the negative 1. Negative 2 times negative 1 is positive 2. 7 times negative 1 is y to the negative 7. 2 times negative 1, z to the negative 2. All over x to the 8th, y squared, z to the 1st. So then I got to deal with the negative exponents before I can do, any dividing of like bases. So and then they move independently of each other. So that 3 to the negative 1 is going downstairs. So it becomes 3 to the 1st downstairs. Then my y to the negative 7, it's going to go downstairs as well. And so I'm going to go ahead and write my x to the 8th, y squared, and z, because those aren't changing. So my y to the negative 7th becomes y to the positive 7. And finally, I've got the z to the negative 2 also has to come downstairs. Oops, but it becomes a positive 2. So upstairs we have left just an x squared. So remember, this is the only thing that's left upstairs, so there's my x squared. These three were there originally, and then I moved these three items here, here, and here. Now we've got to multiply like bases down here, so we have to add the exponents. So I get equals x squared over 3. Then I only have one x term downstairs, so x to the 8th doesn't change. But my y's, I have a y squared and a y to the 7th. So we're adding, because we are multiplying like bases, so I get 2 plus 7 is 9. So y to the 9th. And then I have two z's, because this is z to the 1st. So 1 plus 2 is 3. So I get z to the 3rd. And now I can deal with dividing like bases. So when dividing like bases, we're going to subtract the exponents. So there are more x's in the denominator. So I'm left with nothing up top, so there's a 1. And then 3, x to the 6th, y to the 9th, z cubed. Okay, last problem is 32 over 2 to the 8th. Well, I can actually take 32 and prime factor it. If you prime factor 32 and break it all the way down to its primes, it is nothing but a bunch of 2's. So if you prime factor it, you get 2 to the 5th, and then we already have it over 2 to the 8th. So then I'm just dividing like bases, so I can subtract their exponents where there are more. So there are more on the bottom. That leaves me nothing up top, so I have a 1. And then 2 to the 3rd. Well, 2 to the 3rd is 8, so you get 1 over 8. And that's, make sure I got them all. Yep. So that is all of your answers. So hopefully you did well at that. If not, shoot me some questions. Have a good day.